In the world of industrial automation, the 420 mA current loop is essential for transmitting sensor data over long distances with minimal noise. A key player in this loop is the RL load, which is the resistance found in the receiving device, like a PLC or DCS. This resistance creates a voltage drop that allows the device to interpret the current signal, translating it into meaningful measurements like pressure or temperature. This RL load is crucial for accurate signal measurement and ensures the transmitter operates within its compliance voltage range. If the resistance is too high, the transmitter may struggle, leading to inaccuracies. Understanding Ohm's law helps us design efficient loops, minimizing energy loss while ensuring reliable signal transmission. The RL load is not just a technical detail, it's vital for the performance and accuracy of our systems. The RL load in a 420 mA current loop is crucial for accurate signal transmission in industrial automation. It represents the resistance in the receiving device, like a PLC or DCS, where the current generates a voltage drop. For instance, with an RL of 250 ohms, the voltage drop varies from 1 volt at 4 mA to 5 volts at 20 mA. This conversion is vital for monitoring physical parameters like pressure or temperature. Moreover, the RL load impacts compliance voltage. If the total resistance is too high, the transmitter may struggle to drive the loop effectively. It's all about maintaining accuracy. Using the right RL value prevents signal distortions and ensures reliable performance. Understanding Ohm's law helps us design efficient loops, minimizing energy loss while maximizing signal integrity. The RL load is not just a number, it's the backbone of effective communication in automation systems.